Hi, in this video we shall write a Python program to check if a number entered is a happy number. So what exactly is a happy number? 94 is a happy number. How? If you look at individual digits of this number, you get 9, 4. If you square them and if you add them, you get 81, that is 9 square, plus 16, that is 4 square. So you get 97. Now we take 97, that is 9 square plus 7 square. So we get 81 plus 49, that is 130. Now again we take 130, take individual digits of the number. So we get 1 square plus 3 square plus 0 square. So that is nothing but 1 square is 1, plus 3 square is 9, plus 0. So we get 1 plus 9 is 10, 10 plus 0 is 10. So we get 10. Now take this 10. 1 square plus 0 square is equal to 1 plus 0, that is equal to 1. Now, if you observe, we have arrived at 1. Yeah? So a number which arrives at 1 in this manner or in this fashion is a happy number. So now we've looked at what is a happy number and how it works. Now let's go ahead and write a Python program for this. Okay, so now I'm on my Python interpreter. So we'll start the program. So I'll capture the input in a variable a. So the type is integer. And to take the input, we use the keyword input. And here you can give it within single quotes or double quotes. Let's enter the message. So we'll say enter a number to keep it very simple. Okay, /n, so that the number which is entered goes to the next line. And the output looks neat. Okay. Now we shall take a while loop for this. So let us assume the same number, that is 94. So we'll say while 94, that is a, is greater than 0. We come inside that while loop. Let's take another variable c. So c is equal to the entered number, that is 94, that is stored in a, modulus 10. Why modulus 10? Because we're going to extract the individual digits from the number. So any number modulus 10 will give you the remainder. So 94 modulus 10. 90 modulus 10 is 1. Extra is 4. So 4 is the remainder. So we get the last digit of 94. That is 4. So that is the reason we use modulus 10. Now once that 4 is captured in C, we need to take away that 4 from that number because we no longer need that 4, that particular digit. Maybe we might have another 4 in the number, but that particular position in which the 4 is there, we don't want that number to be repeated. So we divide a by 10. So we get 90. Okay. So now we have taken care of capturing the digit and deleting that digit from the number. We need another variable. So we'll take s, we can declare in the same line to reduce the lines of code. 0. S is nothing but sum over here. You can take any variable name for that matter. So s is 0. So I will take a shorthand operator. S plus is equal to whatever digit we have captured in C. So we're going to square that and we are going to add it to S, that is a sum. Sum is 0. Sum plus the square of the digit captured in C. So it is going to be C into C. Why C into C? Well, it's because it's a square. And now let's come out of this loop and print S. Let us check what is the sum. So we're going to run the program. enter number, we'll go with 94, we'll go with different numbers of course, insert equals there, and now run the program and enter 94. Look at that, we get 97. When I showed you on the whiteboard, we got the exact number, that is 97. Now we need to consider 97 as A, but the input given by the user was 94. Now the same procedure has to be applied on 97. It's that simple. So to do that, we need to assign the sum to the input number. A is equal to S. What is S? S is the sum, that is 97. So A becomes 97, and this goes on. But this comes outside the loop, so it doesn't make a difference. So what do you think can be done? Well, we can come here and have an entry loop that is infinite, but entry loops shouldn't be infinite unless and until you want them to be infinite as the logic demands. So let's have the indentation going on. So look at this, this makes a huge difference. So this is an infinite loop. How do we make it false? Remember, I showed you if the sum is equal to 1, it is a happy number. So we shall say if sum, that is S in my program, is equal to 1, then we print it's a happy number. You can give any customized message. Okay, since this is an infinite loop, we need to quit the program as soon as it's a happy number. We don't want to proceed further. So we'll take the function quit. This is very much different from the break statement. Break, this will break only this while loop. This while loop will still carry on, but when we use the quit, the flow of execution stops and we come out of the program. Okay, let's run the program. I'm not typing the whole program so that you understand the logic, you understand the functionality, the process that goes behind the working of the program. So as usual, we'll give 94. Look at that, there is nothing happening. Why? Let me tell you why. Because S was 97. S is been assigned to A, so A becomes 97. Now this also has become an infinite loop. How do we solve this? So I'll take off that statement. I will ensure that I reset the value of sum to 0 after its job is done. After this loop, after this particular loop in which it is selected, as soon as it comes out, the value of sum is assigned to the variable A, that is the input variable, that will be changed and will be updated. So this is the condition, not worry about it too much as of now, and this will be initialized to 0. If I give this S is equal to 0 over here, let us say if I give it over here, then what do you think is the value of A? A is 0, so we're not going to do that. Now let's run the program and give a different happy number, that is 23. Look at that, it's a happy number. Another example, 19. It's a happy number. The same way, let's reverse that number, 91. 28. Look at that. So no matter how many numbers you're going to give, it will show if it's a happy number. So look at that, in just 11 lines of code, we can validate the fact whether an entered number is a happy number. Okay, so that's pretty much for this video. Please do subscribe this channel. Thank you so much for watching. Bye for now.